Okay, so we are now working on the ideal gas law. All right. If you have one gas that you're working with, how are the pressure, volume, moles, and temperature all related? You still have, here's your Boyle's law, and then you have, which are inversely related, pressure and volume, and then you have your uh, pressure and temperature, and volume and temperature are directly related, as is the volume and moles and pressure and moles. And this is just has all these things together in one gas law. So we have a gas cylinder. It's filled with 5.5 moles. So I know that N equals 5.50 moles. So as always, you just read carefully and then write down what you're given. I have 350.0 kelvins, and I know kelvins is temperature. So 350.0 Kelvin. So that's my temperature. The piston is compressed, right? Because gas, we can change the volume of it. Compressed means we're squishing it, squishing all those molecules together. And so we get a new pressure of, or a pressure of 400. So I have a pressure of 400.0, and then kilopascals is my unit for pressure. And the unknown is the volume. The volume is what I'm trying to find out. Okay, so here are my givens, here's my unknown, and here is my ideal gas law. Pressure times volume equals the moles times my constant times temperature. All right, so I write out this equation and then I substitute. So pressure is 400. I'm going to take out the units because I'm just doing the math here. Volume, I do not know, so I'll leave that as V. N is the number of moles, so that is 5.50. Here's my constant. Because I'm using kilopascals, uh, cubic decimeters, moles, and kelvins, I'm going to use this constant of 8.31. All right, and then the temperature is in kelvins, which is great. I don't have to do any conversions, so 350. All right, now I want to get volume by itself, so I have to get rid of the 400. So I'm going to divide that on both sides. All right, that's 1 times V is V. And then I'll do this over in Desmos, my 500 times, let me move, 500 times my constant times the temperature, which was 350. All right, and then all that divided by 400. Okay, so I'm looking for my new volume. All right, and what I had significant digit wise is I have 3 significant digits. My temperature was 4 significant digits and then 4. So I need 3 significant digits. So I can say that's 3,600, and then that would be um, 35. Uh, yeah, 35. I'll go ahead and just say 35 point. Um, I'll write this out, 0.625, and then that would be cubic decimeters. All right, now if I only wanted 3 significant digits, that would be 3, 6, and then I look at this third one, I would make that, since this is a 5, that would be to 4. Okay, so I could say my volume is 3,640 cubic decimeters. All right. It just depends. And on your test, you'll have multiple choice. And it'll tell you how many significant digits. So as long as you can do this, you'll be good. All right, so let's change our color. And here we go. We've got a gas cylinder. We've got a volume of 3.00, and that's cubic decimeters, which is also a liter. That contains 8 moles. So N is my number of moles, so that would be 8 moles. And I've got my temperature is 50. So my temperature is 50.0 kelvins. Nice. So I don't have to convert there. What is the pressure? So my pressure is my unknown. All right. So this tells me that I'm using this ideal gas law. Pressure times volume equals moles times the constant times the temperature. All right. I write that equation and then I just substitute what I've got. So my pressure is, I don't know. So pressure is P. My volume is 3.00. Number of moles is 8, right? I'm taking off the units. And according to these units, I would use this constant, 8.31. And the temperature is in kelvins. That would be 50.0. Okay. I want pressure by itself, so the 3.00 is what I want to get rid of. So I'm going to divide because these are multiplied. So I'm going to divide. Got to do both sides. And I got pressure times 1 is pressure by itself. And then I'm going to put this into Desmos over here. So I've got 8 times 8.31 times 50.0. All right, divided by 3.00. All right, and that came out really nice. 1,108. And so what's the units? If it's pressure, look at your constant. We're using the 8.31, so that would be kilopascals. And then that would be my final answer. All right, and that's all there is to it, okay? The idea, if you can do the combined gas law, you can do the ideal gas law. All right, I'll do one more, and then you should be able to do these on your own, I think. So let's see, let's change color, we'll go to green. And we've got a gas, so we're thinking gas laws. Temperature is 250 kelvins. Pressure is 75 kilopascals. I've got a volume of 14 cubic, right? The little 3 means cubic, and then this is a decimeter. All right, which is also a liter. And it says how many moles. So N is what I'm trying to find. That's my unknown. So I read carefully, write down my givens, figure out what I'm trying to find, my unknown, and then write my equation. So this would be the ideal gas law. Pressure times volume equals moles times my constant, a variation there, times my temperature. So now I just substitute. Pressure is 75. Volume is 14. Number of moles I do not know. According to these units, I'm going to use 8.31 for my constant. And my temperature is 250.0. Okay. So I want N by itself. So I want to get rid of the 8.31. Boom. So I've got to do that on both sides, 8.31. I also want to get rid of the 250. Now these are multiplied together. Boom. All right. So this 8 times 250, that's a number, and I'm dividing by that same number. Okay, so those go away, but I've got to do that on both sides. All right, and this just reduces my errors because I'm not rounding a bunch of times, and I don't have to write up things a bunch of times. So I'm going to put 75 times 14, right? My pressure times my volume, divided by my constant here, 8.31, times the temperature, 250. Oh, I put a comma there. Okay. So now significant digits, I've got basically 75 and 14. That's just two significant digits. So if I was going to do this out to two significant digits, that would be 0.5, and then I've got a 0, right? The digit next to it is a 5, so that would go up to a 1. So that would be two significant digits, right? There's a decimal here, so you start at the Pacific, fly over the zeros, there's 1, 2 significant digits. All right, and that would be moles. So basically half a mole of that gas I've got. Okay, I'm loving my new pen. I hate to stop. Should I finish the page? Maybe I'll do one more. Except I think you've got it. What color should we? We'll do a purple, just to finish the page. All right, so we've got a balloon, 56. I've got helium gas, so I'm thinking gas laws. I've got moles is 56 moles. I've got a temperature is 298. Yay, it's in Kelvin, so I don't have to convert it. Pressure is 105 kilopascals. And I'm trying to calculate the volume. Volume is my unknown. Okay, so I've got pressure times volume equals the number of moles times the rate, constant times temperature. Okay, write my equation and then substitute. So pressure is 105. Volume, I do not know. Number of moles is 56. The constant, according to these units, would be 8.31. And the temperature is 298. All right, so I just substitute. Write your equation, substitute. And then I want volume by itself. It's being multiplied by this 105, so I'm going to divide by 105, and I'm going to divide this side by 105. 1 times V is V, so my new volume is whatever that is. So let me do that over here. So 56 times 8.31 times 298, my temperature, divided by my pressure, 105. Oops. All right. So basically everything was in whole numbers, right? So I'll just make this a whole number. And that would be 20, right? But then the digit after it is a 7. So I'm going to make that 21. And then that would be, my units would be cubic decimeters. All right, very good. That's awesome. And that's that first page. So you can go ahead and finish the rest, and then you'll be ready for partial pressures.